In this section, we are going to be talking about how to factor polynomials by grouping. So I want to start off this video with the tree map that you've seen before, and it's factoring polynomials. Hopefully this is a pattern and you're sick of hearing this. Our first step always when factoring polynomials is to always check if there is a GCF first. Take out the GCF and then ask yourself, can I keep factoring? What are the different methods that we use? The first one is the difference of squares. So if it fits the pattern of, are you able to take the square root of the first term? Are you able to take the square root of the second term? And is this a subtraction sign? Then it's a difference of squares, and you factor it. The second method we looked at is a basic trinomial. Is it a basic trinomial? A basic trinomial, remember, is when your x squared term, the coefficient is 1. Is this factorable? If you can multiply and get c and add to get b, then it's a basic trinomial. We found those two numbers and then we just split them up. X plus 5, maybe it was x plus 4. It was a basic trinomial. The third method was, is it a trinomial where a is greater than 1? And if it is, a is greater than 1, we either reverse boxed it, we filled the inside, or we did the grouping. Okay? So we had two different ways that we factored where a is greater than 1. Well, today we're going to talk about the grouping method. And the grouping method of factoring is when you have 4 terms. Because we've already done grouping over here, this section is going to be a breeze because you already know how to do it. So those are the different ways we do factoring polynomials, remembering we always go with GCF first. Okay, so let's take a look at our notes. I don't know what's going on here. Let's take a look at our notes and start with the grouping. You've already seen this. So we group the first 2 terms together and the last 2 terms together. So remember when we start with polynomials, there is an order to which we do it. We put the degrees, highest degree down with a constant term at the end. So we're still going to rearrange our terms just like that. And then we are going to split them into 2 groups, just like we did earlier. And we're going to take the GCF out of the first binomial, so x squared, and then I get an x plus 7. And then we're going to take the GCF out of the second binomial. So I'm going to take a 2 out, and I get x plus 7. Now, I have taken what they have in common, x and x plus 7, so that goes there. And then I combine what I took out, the GCF of both of those, and I put them together here. And now I have a binomial times a binomial, and then we can check our answer. So I can distribute, double distribution, x times x squared to get x cubed. X times 2 is 2x, and then I do 7 times x squared, and then 7 times 2 is 14, and then I can rearrange my terms and see, is that what I started at? And I did, so I checked my answer. So that's the grouping method. It's not anything different that you've seen. And when do we use grouping? Well, when there's no GCF, there's not a difference of squares. It's not a trinomial. It has 4 terms. So they're in descending order. I split them into half, take out my GCF, x squared. I get an x plus 4. Take out my GCF of 8. I get an x plus 4, which is great. They better match. If they don't match, I've done something wrong. So I'm going to keep x plus 4, and then I bring in x squared plus 8. Now, if this were a difference of square and that was, well, I'll wait till we get there. Okay, so, and then of course I can check my answer. All right, let's look at number 3. So they're in descending order. There's no GCF. So now I'm going to take the GCF w squared, and I get w plus 5. Remember, I want this second binomial to be positive, and both of these guys are negative. So not only am I going to take out an 8, I'm going to take out a negative 8. Because I need to switch my sign. So negative divided by a negative is a positive. Negative divided by a negative is a positive 5. Now my binomials match, so w plus 5, and then I combine these guys to get w squared minus 8, and of course I can check my answer. Okay, let's look down here. They're in descending order, so I split them into two groups, take out my GCF, p cubed, and I get p squared minus 6. Now, look at the signs. The signs are different. It's negative and positive, and here it's positive and negative, which tells me if it's a sign change, take out a negative. So I'm going to take out a negative 2, and then I get p squared plus, or minus 6, excuse me. And now p squared minus 6, because those are the same, and I combine p cubed and negative 2 to be my second set, and of course I can check my answer. All right, let's take a look. Let's take a look at 11 and 13 and then do some more. All right, is it from least to greatest? It is. It's in descending order. So I'm going to take out my GCF to get 4x, and I have a 2x plus 3. Over here, I can take out a y, and I have a 2x plus 3. These guys match, which is good, because if they didn't, I had done it wrong. So 2x plus 3, and then I combine those GCFs to get 4x plus y. And of course, you can always check your answer. Okay, let's look at number 13. They're in descending order by degree, so that's great. So take out my GCF a squared. I have an a plus b. Take out b, and I have an a plus b. These guys match, which is fantastic. And then I bring together a squared and positive b. And of course, I can check my answer. Okay, now, remember, you always want to look to see, are these in greatest degree? And they're not, so I'm going to rearrange. And I have negative x squared plus 5x plus 2xy minus 10y. So now they're in greatest degree last. I do want to check, do I have a GCF? And I don't. So there's 4 terms, so the only method I can use here is grouping. So I'm going to go ahead and take that out. Now, I always want my leading coefficient to be a positive, so I'm going to take out a negative x to give me x minus 5. And over here, I can take out a 2y, and I get x minus 5. Now, I have x minus 5, and I bring together these guys to give me negative x plus 2y. I'm not rearranging them. I'm still putting them by degree alphabetical order, so I get negative x plus 2y. I don't have one. Oh. All right, look at number 17. Again, I want to rearrange from greatest degree down. So I get 12m squared plus 3m plus 28mn plus 7n. Now they're rearranged. Now I can divide them. Real quick, do they have a GCF? They don't. So I know I'm going to use grouping. So now I take a 3m out, and I have 4m plus 1. I take out a 7n, and I have 4m plus 1. These match, which is perfect. 4m plus 1. And then I combine to get 3m plus 7n. And of course, they don't have anything else in common. And I can check my answer by doing double distribution. So that's grouping. Hopefully it's pretty easy.